Okay, guys, this is lesson 8, Algebra 1, area. This is starts on page 36 and 37 of your textbook. So first of all, an area of a closed figure is the number of square units contained in the figure. So if you look on page 36, you'll see that they have a shape that has curves in it, and they divided that shape into square units. And you can see that one of those square units is shaded. Okay. So any shape that fills a closed figure without overlapping could be used to measure area, but the square is used because of its simplicity. So, um, so for many closed figures with irregular boundaries, we have to break up some of the square units to fill the figure. So it's not uncommon to have closed figures whose areas contain fractional square units. So you can see that on this example. It's rounded, and then it kind of has a square right here. And so some of the units actually contain the square unit, but others do not. Okay. So it's just a little bit harder to measure. Okay. So look at the top of page 37, and we're going to look at the area of rectangles and squares. So this first rectangle, it's not marked, but it's 4 units horizontally, and it is 2 units vertically. Okay, so if we were to mark this off, we would divide it with 4 lines. Well, not 4 lines, but into 4 parts. So we'd use 3 lines to do that. And they would all be evenly spaced. They'd be parallel lines. And then we'd break this into parts. So you can see the 4 units across and the 2 units up. So it takes a total of 8 squares to fill this rectangle. Therefore, the area of the rectangle is 8 square units. Okay, so when we find the area of a rectangle, we're going to do length times width, and whatever the answer is going to be squared. So let's say that this is 4 inches and this is 2 inches, then this would be 8 inches squared. The reason why the unit is squared is because we're not only multiplying that coefficient of the length of each of those, but we're also multiplying the inches. So inches times inches is inches squared. All right. Now, the area of a square, like the area of a rectangle, you still find it the same way, but a square has all the same sides, right? So if this is 2 centimeters, this is also 2 centimeters, and this is 2 centimeters, and this is 2 centimeters. So length times width would be just squaring whatever is there. So 2 centimeters, if we were to square that, would give us 4 centimeters squared. So for a rectangle, it's length times width. And for a square, it's the area of the square is the length of the side squared. Okay, let's look down at example 8.1. All right, we have a shape. It's not a rectangle or a square. It's a little bit different. So we have 2 parts. All right. So we have some dimensions here. We have this is 5 tall, 2 across on that part, 3 high here, 4 across here, 2 up here, and 6 here. And it says that all angles are right angles and the dimensions are in centimeters. So we know we're going to have a centimeter answer. And since all of these angles are right angles, then we can infer that it's just what it looks like, okay? All right, we're going to divide this into 2 different rectangles. So we could split it this way and have a rectangle that is 5 times 2, and then have a rectangle here that is 4 times 2. And then we would just add these 2 areas together, which would give us 18 centimeters squared. Now we can also divide this a different way. Instead of splitting it like that, we could split it like this. We could do 2 rectangles this way. So that would make that one 2 times 3, which is 6 centimeters squared. And then it would make this other one 6 times 2, which is 12 centimeters squared, which if we added those 2 together, it still gives us 18 centimeters squared. All right, let's look at example 8.2. We have an area, we have a rectangle. We know it's a rectangle because it has different height than it does width. It looks about like a square, but it's not quite a square. And we have a rectangle inside of it. And we know that the height, these are in meters. This is 8 meters. This is 10 meters. This is 6 meters. And this is 2 meters. So we're going to find the area of the shaded portion of the figure. So that means we need to find the area of both of these figures. So the area of this whole thing would be 80 meters squared. And the area of this whole thing would be 12 meters squared. But this does not count as the shaded area, so we have to subtract it back out. So this is going to be 68 meters squared. Okay, let's move on to page 38. This is 8C, area of a triangle. So the altitude or the height of a triangle is the perpendicular distance from either the base of the triangle or an extension of the base to the opposite vertex. And any one of the 3 sides can be designated as the base. So if I have a triangle like this, I don't think I can draw different kinds with this program, but we'll start with this. I'll draw a nice one, and then I'll draw freehand for the other 2. There we go. So this first one has this little box right here, which indicates that this is a 90-degree angle. This is the base. If this is the base, then this is the height or the altitude. Okay. This is my perpendicular height, right? So this is where it forms that right angle. So that's how I know that that's the altitude, is because this line goes down and is perpendicular to this base and forms this right angle. Okay, so we're going to do that with each of these. So that's A. Now B, this is not perpendicular and this is not perpendicular. So we're drawing a perpendicular line to the base, and this is our base, and this is going to be our height or altitude. And then in the same way, C, this is not perpendicular. So we have to draw a perpendicular line here, and this is the height or altitude of our triangle. And then from here to here would be our base. Okay, now the area of a triangle is base times height divided by 2. And another way you could look at this is 1/2 base times height. So that means that you could say 1/2 of the base times the height, or 1/2 of the height times the base. And all of these things would get you the same answer. All right, so let's look at our first example for this, 8.3. This A, that's a right triangle. It has a perpendicular line, forms a square corner there. It has a altitude or a height of 3 and a base of 4. So I can multiply base times height together. 3 times 4 is 12, divided by 2, which equals 6. And these are inches, so it's inches squared. So we could do it that way. I could do 1/2 of the base times the height, which would be, this is 4, so this would be 2 times 3, which also equals 6 inches. And I also, we also could do divide the 3 in half. So that would be 1.5 times the base, which is 4, which would also give you 6 inches squared. Okay, so that is A. Then B, it's this other kind of triangle where you have to find the altitude here, and it's given that the height is 3 and the base is 4. Well, you'll notice that this is the same numbers as in our A example. So this is also going to be 6 inches squared. 3 times 4 is 12. 12 divided by 2 is 6. 6 inches squared. All right, and then finally in C, we've got this obtuse triangle. The height is given as 3, and the base from here to here is 4. So this is also 6 inches squared. All right, let's look at 8.4 and see how we do there. This is at the bottom of page 38, example 8.4. And you'll notice that this triangle is flat on the bottom, right? And right above that on C, well, not on C, let's look at B. They drew an altitude in the middle and found a square. But you'll notice that this has a square right here. So that means that this is the height of this triangle, and this is the base. So that means that we can do base times height divided by 2. So the base is 8, the height is 6. 8 times 6 is 48, divided by 2 is 24, and this is in feet, so feet squared. So you can also have a triangle that does not look the same way as your other triangles, but if you can locate where the right angle is, you can find the altitude and the base. Now, the other thing is that it would have also worked because this is a right angle. You could have used this as the base and this is the height, and it would have still given you the right answer. This is your hypotenuse, so you would not multiply by that. All right, let's look at 8.5. Now we have a rectangle with a triangle. All right, so we have this rectangle, and then we have this triangle. There we go. All right. So we have a little bit out of proportion. All right. So this is 6, 4, and this whole base is 10. And these are in yards. Okay. So the first thing you have to do is we don't have a formula for a shape like this. So we have to cut it into 2 shapes. So we do have a triangle and we have a rectangle. All right. So our rectangle, the area is 24 yards squared. But we have to find the triangle as well. Well, the height is going to be the same as the height of this rectangle. So this is 4. And then the base is going to be the difference between this whole entire length here and this part right here. So that's going to be 4. So the way that we would figure this out is base times height divided by 2. So that's going to be 16 divided by 2, which equals 8 yards squared. And then we know that our rectangle is 24 yards squared. So we add those together. So this is 32 yards squared. All right, moving on to area of a circle. Okay, the area of a circle is pi times radius squared. So here's my circle. And the radius is the distance from the center of the circle to any point on that circle. I'm sorry, to any point on that circle's outer edge. So the radius is the distance from here to here. The diameter is the distance all the way across from a point like this. So this whole thing would be the diameter, that straight line, but the radius is half of that. So 2 radiuses equal a diameter. All right. The radius of a circle is 3 centimeters. Find the area of the circle. All right. Well, we are going to use the formula pi times radius squared in order to find the area of a circle. So for pi, we're going to substitute 3.14, which is the abbreviation for pi. Pi is a number that goes on for infinity. And then we're going to multiply that times the radius squared. It says that the radius on 8.6, it says that the radius is equal to 3 centimeters. So we're going to put 3 in here. We're going to raise it to the second power. 3 squared is 9. And then 9 times 3.14 is 2826. This is the handy time for you to use your calculator. When we're multiplying times pi, it's a great time to use your calculator to make quick work of this. Okay, now let's look at 8.7. The area of a circle is 25 square meters. Find the radius of a circle. Okay, we're going to take the same formula and we're going to work it in reverse to find the radius. Now, this is the area of a circle, the formula for it, and we were told that the area of a circle is 25 square meters. So we can make these two things equal to each other. If I make them equal to each other, then I can solve for the radius. Okay, so when I'm solving for a variable, I want to get it all by itself. So I'm going to divide both sides of this equation by pi. And that gives me radius squared equals 25 divided by pi. I'm going to convert pi into 3.14. I'm going to take out my calculator. I'm going to put 25 in. And then I'm going to divide it by 3.14. And that gives me 7.96 and 178, blah, blah, blah. I'm going to go ahead and I'm going to go out just 2 decimal places. So that's going to give me 7.967 and 96 hundredths. But that's radius squared. And I need just the radius. So remember, if I need to find if something's squared, in order to find what it is, so say 9, what times what equals 9? Well, 3 times 3 equals 9, right? So the square root of 9 is 3. That's what I'm doing here too. I'm going to take the square root of both sides of this equation. That leaves me with r on this side. And I'm going to take, in my calculator, I'm going to hit the square root button. And I'm going to get 2.82 because I'm rounding to 2 decimal places. So the radius of a circle that has an area of 25 meters is going to be 2.82 meters. Okay, let's look at example 8.8. Find the area of this figure. Lines that look parallel are parallel and dimensions are in inches. Okay, I'm going to freehand draw this. So I've got a triangle, a rectangle, and a semicircle. Okay, I'm going to split this into a triangle and a semicircle. The radius is 2. The distance from here to here is 5. And the distance from here to here is 7. Okay. Okay. So, things we can infer. All right. We have a radius that's 2 from here to here. So it's 2 from here to any point on this semicircle. So that means it's also a length of 2 from here to here. And it's also a length of 2 from here to here. So that means the height of this rectangle is going to be 2 radius, which is 4 inches. So if this is 4 inches, since all these corners are square, this is also 4 inches, the height of this triangle. Okay, so if I'm finding the area of this figure, I know that inside this rectangle, which I'll just scratch out as blue, that's going to be 20 inches squared because 5 times 4 is 20. All right, now the base of this rectangle is only from here to here. So if this whole thing is 7 and up here is 5, the difference is going to be 2. So the base of this triangle is 2, the height is 4. So base times height divided by 2 is going to be 8 divided by 2, which is 4 inches squared. Okay, so far for the rectangle we have 20, for the triangle we have 4. Okay, lastly, the semicircle. This is 3.14 times the radius squared divided by 2. Okay, so we're going to put 3.14 times 2 times 2 over 2. That will cancel. So it's going to be 3.14 times 2, 6.28. Now we add all of these up. So this is going to be 6.28, 4 inches, and 20 inches. So our area for this shape is 30 and 28 inches square. Okay, let's look at the areas of parallelograms and trapezoids. Okay, so there's a formula for the area of a parallelogram, and there's also a formula for the area of a trapezoid. They're hard to remember because we don't use them very often. The easiest way is to find the areas, and the easiest way to find the areas is to divide the figures into 2 triangles, as we show in the following examples. So on 8.9, we have a parallelogram. That means it has 2 sets of parallel sides. And so the length of the top and the bottom are 8, and the length of the sides on the side are 5. But remember, that's not the perpendicular height. So it's shown here as 4. That's the actual height, okay? So if we split this into 2 different triangles, you'll notice that they have the same dimensions. So we have the area of the first one and the area of the second one. Well, we know that the height is 4, and we know that the base is 8 for each of these, okay? Because this is not the height. This 5 is not the height. The perpendicular base would have to be you have to draw a line down here. So that height is 4. So 8 times 4 is equal to 32, right? And then you would divide, so the triangle, area of a triangle is base times height divided by 2. So base times height divided by 2 is 16 centimeters squared. And that's also going to be the same. So that's area 2. And so area 1 is going to be just the same. So it's going to be 16 centimeters squared. You add those together, and that will give you 32 centimeters squared. Okay, that is for parallelogram. If we're doing a trapezoid, we'll also have 2 triangles, but their bases will not be the same. Okay. The bases won't be the same. So we have one set of parallel lines, the top and the bottom, and then those other slants will not be, they're not parallel to each other. If they were extended, they would intersect. And then we have the vertical height, which is 4. Okay. 4 meters. Okay. We're going to split these in half, and we'll say the area of 1 and the area of 2. Okay, so the area of 1 has a base of 9, base times height divided by 2. So that's going to be 36 divided by 2, which equals 18. And these are in meters. And then the area 2 is going to be 15 times 4, which is 60, divided by 2, which is 30 meters squared. And then you would add those two together, 30 meters squared plus 18 meters squared, which equals 48 meters squared. Okay, so that's how you do a trapezoid and a parallelogram. So I want you to go ahead and do the practice problems. I'm going to go ahead and do them too, and I want you to go to check them. All right, go do that now. Okay, guys, here's the answer to A through D. Check your answers. See if you can see where you can pause this and look at it and see if you can see where you may have made a mistake. If you need help with these, I can help you during math lab at the end of the day on Tuesdays and Thursdays. Or we could set up an appointment online probably as well. Okay. See you guys on Tuesday. Bye.